Hello student, myself Jitin Sai. So today we are going to discuss about the chapter 4 of microprocessor, that is microprocessor based system development aids. So first of all we will discuss about the concept of interfacing. Interfacing is a technique to connect the input devices, output devices and memory to other peripheral with the microprocessor. We know that the microprocessor is useless until and unless we don't connect any peripherals with it. So for communication purpose, in between microprocessor and peripheral interfacing is required. Next, what is mapping? Mapping is a technique by which we can address various memories, ICs, and it is of two types. One is memory mapped IO or memory mapping. Second one is IO mapped IO or IO mapping. Then differentiate between the memory mapped IO and IO mapped IO. So in terms of addressing, IO devices are assessed like any other memory location, but the IO mapped IO devices cannot be assessed like any other memory location. Then in terms of address size, they are assigned with 16-bit address values, but memory mapped IO devices are assigned with 8-bit address values. Then in terms of instruction used, the instruction used are LBA and STA in case of IO, memory mapped IO, and in case of IO mapped IO, the instruction used are in and out. Next, in terms of cycles, cycles involved during operation are memory read and memory write, but cycles involved during the operation of IO read and IO writes in the case of IO mapped IO. Next, in terms of registers communicating, any register can communicate with the IO device in case of memory mapped IO, and only accumulator can communicate with IO devices in case of IO mapped IO. Next, in terms of space involved, 2 to the power 16 IO ports are possible to be used for interfacing in case of memory mapped IO, but only 256 IO ports are available for interfacing in case of IO mapped IO. Next, in case of IO by ember signal during writing or read cycle, IO by ember equals to 0 in case of memory mapped IO, and during writing for read cycles, IO by ember equals to 1 in case of IO mapped IO. Next, in terms of control signal, no separate control signal required since we have unified memory space in the case of memory mapped IO, and special control signals are used in the case of IO mapped IO. Next, in terms of arithmetic and logical operations, arithmetic and logical operations are performed directly on the data in the case of memory mapped IO, and arithmetic and logical operations cannot be performed directly on the data in the case of IO mapped IO. Next, we'll discuss about the memory mapping. So, memory mapping is the technique in which memory location are identified by input and output devices. So, advantage of memory mapping are more than 256 number of memory location can be specified by this technique. The CPU can be transferred the data within the input or output device directly with the accumulators. So this technique is very fast. Then disadvantages are due to the wider address space, the interface hardware is complicated, the complexity of the program is very large. Next, IO mapping. So in this technique, the IO means input output devices are considered as a memory location. This technique requires two specific instructions that is in and out. To access I/O devices, we require two control signals, that is I/O R bar and I/O W bar, that is I/O read bar and I/O write bar. So we cannot access more than 256 number of I/O ports. Next, advantages. Address space is very less. Only two instructions are used. And disadvantage is the microprocessor pin must generate control signal to distinguish between memory and I/O operation. Next, the next topic is memory interfacing. So this is the logic diagram for RAM and this is the logic diagram for EEPROM. So microprocessor 8085 can access 64 kilobytes memory since address bus is 16-bit. But it is not always necessary to use full 64 kilobytes address space. The total memory size depends upon the application. Generally, EEPROM is used as a program memory and RAM as a data memory. When both EEPROM and RAM are used, the total address space 64 kilobytes is shared by them. The capacity of program memory and data memory depends on the application. It is not always necessary to select one EEPROM and one RAM. So we can have multiple EEPROMs and multiple RAMs as per the requirement of application. Next, we can place EEPROM or RAM anywhere in full 64 kilobytes address space. But program memory EEPROM should be located from address 0000H since reset address of 8085 microprocessor is 0000H. It is not always necessary to locate EEPROM and RAM in consecutive memory. For example, if the mapping of EEPROM is from 0000H to 0FFFFH, it is not must to locate RAM from 1000H. We can locate it anywhere between 1000H and FFFFH. Where to locate memory component totally depends on the application. Next, the memory interfacing requires to select the chip, identify the register, and enable the appropriate buffer. So, microprocessor system includes memory devices and I/O devices. It is important to note that microprocessor can communicate, that is read or write, with only one device at a time since the data, address and control buses are common for all the devices. In order to communicate with memory or I/O devices, it is necessary to decode the address from the microprocessor. Due to this, each device, that is memory device and input output device, can be accessed independently. The following section describes the common address decoding techniques. Next is address decoding technique. So absolute decoding or full decoding, linear decoding or partial decoding. There are two types of address decoding. So first of all, we will discuss about the absolute decoding. So in absolute decoding technique, all the higher address lines are decoded to select the memory chip, and the memory chip is selected only for the specified logic levels on these high order addresses or address lines. So no other logic levels can select the chip. So the figure shows the memory interfacing in 8085 with absolute decoding. So this addressing technique is normally used in large memory system. So this is the diagram of absolute decoding technique. Next, linear decoding. So in small system, hardware for the decoding logic can be eliminated by using individual high order address lines to select the memory chips. So this is referred to as linear decoding. So the figure shows the addressing of RAM with linear decoding technique. This technique is also called partial decoding. So it reduces the cost of decoding circuit, but it has a drawback of multiple address. Next, programmable peripheral interface 8255 PPI. PPI stands for Programmable Peripheral Interface. So the peripherals cannot be connected with the microprocessor directly. So we use 8255, which is known as the Programmable Peripheral Interface PPI. So 8255 is a general purpose programmable device used for data transfer between processor means microprocessor and input output devices. So it has three programmable by control word in the it has three programmable input output ports, that is port A, port B and port C, and port operation, that is in or out port, is defined by the control word in the control word register. So ports are operated in two modes. One is IO modes. So IO modes is again of three types: mode 0, mode 1 and mode 2, and second one is BSR mode, that is bit set and reset mode. So this is the block diagram of 8255 PPI. So the block diagram consists of two group control. One is group A control and second one is group B control. One data bus buffer is used. The data bus is bidirectional. Here the data is transferred in both direction, that is from input output devices to the microprocessor. And group A consists of port A and port C offer, and group B consists of port C lower and port B. So here three ports are available: port A, port B and port C. So port C is again divided into two halves. One is upper and second one is lower. So each port is of 8 bit. So port A means PA0 to PA7, port B means PB0 to PB7, and port C means one is upper and second one is lower. So upper means lower means PC0 to PC3 and upper means PC4 to PC7. Next, one 8-bit internal data bus is present, and one read or write control logic block is present. So it consists of read bar signal, write bar signal, A0, A1, reset and CS bar. CS stands for chip selection. And here power supply is plus 5 volt. Plus 5 volt is given to the 8255 PPI. Thank you.